All right, previously we learned that when an object is more dense than the fluid it is in, it's going to sink. Similarly, if it's less dense, it's going to rise. If they're the same density, it'll float. We also learned that if the gravitational force on the object is greater than the buoyant force on the object, it's going to sink. If they're the same, it's going to float. And if the buoyant force is greater, the object will rise. So we have two ways of determining whether an object is going to rise or whether it's going to sink. So we should be able to relate these two concepts mathematically. Okay? And that is what we're going to try to do today. So let's say we have this object. We place it in the water. Okay? What's going to happen? Well, the level of the water is going to rise. Okay? And that's because the volume of this object, okay, is going to be that much water will be pushed out of the way. Okay? So one thing we know is if we put the object into the water or into a fluid, okay, and the object is completely submerged, then the volume of the object is going to be equal to the volume of the displaced fluid. Okay, all it's saying is the volume of this ball that I put in the water is equal to the amount of water that got pushed out of the way. Okay? So what we're going to do next is we're going to look at some equations that had volume in them. Okay? Well, one equation that we have that had volume in it was the density equation. And the density equation said that the density of an object is equal to its mass over its volume. Okay? And we've got volumes equal to each other. So we're going to solve this equation for volume. So multiply both sides by volume. Okay? So we have volume times the density is equal to mass. Divide both sides by the density. We have volume is equal to mass over density. Okay, so for the object, we need to use the mass of the object over the density of the object. And for the displaced fluid, we need the mass of the displaced fluid divided by the density of the displaced fluid. The next thing we're going to do is we're going to go ahead and multiply both sides by the gravitational field constant. Okay, remember, in math, as long as we do the same thing to both sides of the equation, it's still equal. So multiply both sides, gravitational field constant. Now, you look at this part of our equation. What is that? That's the mass of the object times the gravitational field constant. In the past, we've called that the gravitational force. Okay? Look at this part. This is a little bit new. The mass of the amount of displaced fluid times the gravitational field constant. We just learned about that. We call that the buoyant force. Put the B first by accident. The buoyant force. Okay? And then we still have the density of the object and the density of the fluid. Okay? So this is our new equation. All right? However, the book rearranges it, and if you want, you can go ahead and rearrange it yourself, just solve around. And the book has it written like this. The gravitational force over the buoyant force is equal to the ratio of the density of the object over the density of the fluid. Okay? So you'll see it on your equation sheet written this way, and in the book written this way. When we derive it, it's like this. We can go ahead and solve it down to this if we'd like to. One thing to take note of, this gravitational force, this is the gravitational force of the object in air. Okay?